My name is AD Burrows. I'm from cgmasters.net, and before that I worked at a games company called TT Games, and a part of that was TT Fusion, part of the whole Warner Brothers interactive entertainment stuff. And I've kind of rolled forward to about a year ago. We were thinking to do some kind of project trying to test what Blender could do with a certain theme. And so we hooked up with Gleb Alexandrov from Creative Shrimp, who's this really unknown kind of up-and-comer. Actually, no, he was just on that screen over here. It's like the only face I can make out at the moment because it's very bright. But yeah, so we got together and thought, well, let's do something to do with space, because first of all, it's like a super inspiring kind of backdrop to use to create loads of inspiring stories, and it just looks cool anyway, so that's a good start. And so we basically got together, sort of saw how could we do that, and then try and share a lot of those ideas. So the problem with space is it's a bit on the big side, and what happens there is you get something like this. That just, even as a slide, that makes me wince. But basically, we're going to need to find a lot of ways to kind of get around how do you actually really do that? How do you create some sort of astronomical scenes? Because we kind of agreed that we didn't necessarily want to represent it as a kind of a scientific project. We kind of felt sort of compelled to give that idea a go because you know, something about the Blender community makes us think it should be as authentic as possible and everything. But we kind of went with the kind of more leaned heavily on the artistic side and kind of the cheating side of it, if you will. So it's not kind of obviously a problem completely unique to us or anything. This is an issue that has been, you know, dwelled with a lot and kind of really delved into deep on many different films and projects and so on. So, for example, other people have cheated, and kind of it's the illusion of things. So, for example, on the left here, this R2-D2 might be surprising for some people in the Netherlands to see that there are people this small that can fit into like a little thing like that. And then, and similarly to the people in the Netherlands, that person isn't normally sized. This isn't. Yeah, actually, yes, of course, that isn't a giant or anything. That obviously is a miniature. So obviously creating an illusion is perfectly fine. It's completely okay to kind of just do whatever it takes to get the job done. And obviously the audience is along with you on the ride to kind of suspend disbelief a little bit. So with that in mind, we wanted to try and break down how to try and sort of get into the various things that we were going to need to do, which was basically create some sort of infinite detail, I suppose. So that was kind of borrowing and stealing other tricks and tips from other things. So for example, working in the games industry, something that's very, very common that you might do is work with a seamless texture, meaning all the very borders of the image. This is obviously not exactly that fresh an idea, but at the very end, you just make the image tile so that the very borders of this image don't look like they kind of stop at a very clear line, and instead sort of tile. And you can kind of get away with that a little bit, but if you scale it up too much, you're going to start seeing a pattern. But if you apply that very same texture just to kind of a sphere, basically, and light it, you can kind of see you don't really get to see very much in the way of repetition. But if you zoom in on that, even with, say, something like a 16K texture, so depending on what the kind of space shot we wanted, you know, what kind of ships were kind of flying through this thing and that we wanted to kind of keep on top or something, if you get too close into a planet like that, obviously you're going to need to find a different solution. So just tile it up. But from this vantage point, I guess you can see that you can start to see lots of repetitious detail. But when you zoom in, it starts to look okay. So it's going to look okay at one scale, but it's not going to look okay at another. But that's kind of a little trick in itself, because I've jumped forward there. That isn't as tiled as it was in the last scene. It's actually tiled like that. So, you know, we need an issue. We need some sort of kind of way to be able to get through that. And yes, that's a GIF, and it's actually playing the movie. All right, cool. So we have this seamless texture on the left of this asteroids, and on the right-hand side there, you can see basically what we're doing is fading into that texture. You can just about make out, like if you get the right kind of point that you zoom in, fade into it, then you can have it so that it doesn't look too obviously just suddenly fading in. This is the kind of setup for that. So I wanted to try and put as much technical detail, like kind of node kind of specifics in this talk as possible, which some people might find a bit frustrating or slow or something, but I'm just going to try and get through this as quickly as possible. So on the top there, that's the not tiling version. At the bottom, that's tiling lots and lots and lots, and it's going into this end mix node over here. So basically, those are the two textures which go into that mix node. The thing that's driving the factor, though, is this camera data node. We're taking the view distance out, and we've got the first math node is just set to divide, and then the value you give it is going to be the amount of blender units where this kind of distance fade starts to kick in. So at 1.5 blender units in, it's going to start fading into that, or the second texture. The thing is that this next math node that we have there, that's set to power. That is a distance speed, I suppose you could say, the fade speed, I should say, and it's set to 1 at the moment, so it's not going to do anything. But if you kind of crank that right up, it can fade really, really quickly into that next image. So you can kind of really, really fine-tune that. And then also, another way to be able to get as much detail as possible is to take a look at more procedural texturing. So that's where this noise texture is amazingly useful. Even just as simple as that, you can get a lot of that. Get a lot out of that, but we'll come back to that in a little bit. What I wanted to talk about first is the fact that that same kind of procedural texture, it just doesn't have to kind of influence the actual visual pixels of it in terms of sort of color and brightness and so on. It can actually distort the positions that we've probably all seen. So here's a kind of pebble-shaped sphere that's been just kind of squashed a little bit, and you can see more or less the resolution of it. But obviously, if you kind of take those same sorts of procedural textures, you can see what we're using on there is we're taking it into a displacement modifier, and it's using that procedural texture that you can see on the bottom right. And then we kind of just smooth it a little bit. But the key thing that we're doing there is, let me see if I can just point to this field here. You can see that that bit is where we're setting another object as its coordinates, and that becomes important a little bit later on. But otherwise, we can just sort of start stacking up lots and lots of these procedural textures on top to kind of get the various different details that we were looking for out of asteroids, because it was obviously going to take us a very long time to create a lot of asteroids. So we need to figure out ways to do that. And you can see you can use the color ramp down there to really kind of start to change where you fade into brightnesses and the various dark values. So you can get the bright bits are going to push it out, and the dark bits are going to push it in. And mid-gray should leave it flat. And then put it through, just put a bit of a diffuse texture on there, similar as we were looking at before with that same seamless texture. And then what we're doing here is, as I was saying about the texture coordinates that we're using another object, which was just stay in place. You can see that we've got these 4 different asteroids, but have a different kind of portion of that texture. So you can kind of, as long as we move the asteroid somewhere else, you've got to get an infinite amount of asteroids, basically. So then we just put that into an asteroid field, throw some other little bits and pieces of effects in there. So with that, though, by the way, the farther away that you get from the camera, it's OK to just go on very low resolution. Otherwise, you'll get that second image that we did before where it's just out of memory. So anyway, right, bringing some of those same sort of ideas to taking a look at planets. We've got this image here, which on the left-hand side, we just got a moon texture. And if you combine that with, say, a Mars texture, but use a third texture, like this IO here that we've got, as a mask, you can see the results of that on the right-hand side. And then you can sort of change the texture position and create any number of unusual planets very, very quickly, like these, for example. But you might be thinking, well, what do you mean by just grab a texture? Well, these are the sorts of textures that we'd get. So these equirectangular maps are really useful, very easy to apply to the model. And you can see that this is the location of where we got this image at the top. Like, for example, that's the website there. If you want to grab and do similar things, they're kind of mixed from the NASA details, I think. And this is another one. This is Mars. And then you've got there the NASA 3D resources, which are really good. So if anyone wants to kind of dig into that in more detail, I highly recommend it. It's got really cool 3D models as well as textures on there, blend files even, sort of like the Curiosity rover and things like that. It's really cool stuff. And that's what it looks like when we apply that Mars texture, for example, onto the sphere. You can see the little red arrow there. All I'm doing is actually literally just putting it on, just a really simple shader, just putting the, just changing that texture coordinates there to the sphere option. And basically, it does the rest for you. It's really, really easy. But if you did need to do it in UVs for some reason, so for example, you were taking it into a game or something, then now in 2.79, we have the generate UVs, and we actually get, this is only available when you actually create the object though, and it actually does deliver you some pretty decent UVs, which look basically like that. So you can tweak them a little bit if you want to at that stage, but that's a much faster than what we had to do before. And now what we can do is, basically, if we want to transfer what we did in the really, really super simple version that we did before, because we were trying to do things as fast as possible, you can see that we've got, you can see we're basically selecting that object. And at the top there, those 4 top nodes, those are the ones that we saw from before. That's what's actually showing on the planet. But this texture at the bottom, just create a new texture at the dimensions you want, and then hit bake for an emit pass. And then you've now got your UVs, so you can now bake out that texture and then apply it onto the model. And it's super simple if you want to get it into games and stuff. So let's take a little bit more of a look at the noise stuff. So yeah, let's see. So with this, we wanted to take a look at kind of create a procedural planet, basically. So one of the issues with that is that what we want to do is be able to create node groups and so on, or at least kind of suggest how you might be able to do that. And one of the issues, or one of the ways in which it makes it very quickly and easy to get confused, is that the fact that the color ramp, which is awesome, you can just use really easily, just shift that black flag thing over here, sort of towards the middle, and then you're going to kind of crunch down all that lower end. Instead of it being black to mid-gray now, we're going to sort of remove a lot of that black to mid-gray, and now that's all just going to become black. So the problem with that, though, is that we can't really plug those sliders into kind of a group node, which was talked about on another talk, in fact, actually, which I recommend checking out from Mad Animation, I think it was. And they've got a really cool node set up to be able to deal with that. This is another way to be able to deal with that. It's possibly kind of just a simpler kind of hack, I suppose. But what we could do is, instead of using the color ramp, just use the RGB curves instead. Which is, if you click on one of those points, you get this little X and Y at the bottom there. And now if you just kind of move that to 0.5, it basically does exactly the same thing as we did before. So just kind of just comparing the color ramp at the bottom and the RGB curves, they're basically exactly the same. The problem is that on the outside of that RGB curves, though, we're going to get some crazy figures, because that can go way outside of 0 and 1, or way below 0 and way above 1. So sometimes you might need actually just a color ramp anyway at the end of it, just to sort of clamp off those details, otherwise you can get some crazy stuff. But otherwise, once you have that, you then have the special thing about the RGB curves is that we have the factor slider. So once we take that at 0, we're not using it at all. And then when we slide it all the way down to 1, it's kind of the same thing as just chucking your black flag of that color ramp and plugging it all the way over. So it's basically now you have a slider that you can actually plug into a kind of node group or something. Ways to kind of get a little bit further with that is the fact that you can plug in a mix node into the factor of the RGB curves, and then just set up 2 value nodes to kind of give you your, whatever you want to set as your boundary, so what your lowest value is and what your highest value is. So for example, in the RGB curves node by default, that goes down to -1 and up to 1. But if you want to go outside of those values, you can do. So for example, with a color ramp, you just want to go from 0 to 1 often. So you can just kind of set up that. And then to do the other side, kind of the white flag, you can see these sorts of nodes over here. Just those last 4 on the side, that's basically exactly the same setup as this, but instead of it doing it for the moving the left-hand side over, we're just moving the right-hand side over. And now we've got 2 sliders, which would be this value here and that value, we can basically just plug that into a node group if we wanted to. So with that, we can take a look at some of the noise that we can put into other things. So for example, we did this kind of the gas rings, instead of obviously modeling the individual pieces of dust. If it's far enough away, what we can do is just use, again, more noise. So just create a disk of geometry, just a single layer, and then use the wave texture. So what we've got here is the texture coordinates going into a wave texture. In fact, actually, no, sorry, the texture coordinate isn't going into that wave texture yet. It's just using the generated coordinates by default, which gives you this kind of crazy idea, which I wonder if that's somewhere in the universe. Oh, but anyway, all right, so you have this object coordinates that you can put into this wave texture instead, and that gives us what we want, but it's kind of a bit too uniform, a bit too, obviously, it just looks way too more, just too simple. So what we want to do is simply plug that wave texture instead into a noise texture and just kind of control that scale there until we get something that we think looks appealing. And then from there, we just want to add in a gradient texture, because otherwise you're just going to get that harsh transition at the very edges of the geometry. On one side, you have, so we're just going to plug in that gradient texture, again, informed by some UVs. So just kind of separate out the UVs into just a flat line. And then what we want to do is take that gradient texture into the color amp. Color amp's going from black to white to black, which we can see from the very edges of the geometry that we've got. And then it's going into a power node just to control the fade. So when we add them together, well, multiply them together, I should say, with this node at the end, we can then get the whole detail. And that's just a really simple shaders, like couldn't be simpler really. Just going into a mix shader, into the factor, transparency, and diffuse, so that you can get the shadow of the planet kind of obscuring a lot of the areas of the actual rings themselves. So let's take a little bit more of a look at some noise. So nature's pretty noisy. It's good to get a good handle on that noise. So basically every scale, so you've got like the Brownian motion of like a suspended particle of pollen in fluid, and from the noisy pattern of a mosquito flying around, or like clearly the arrangement of stars in the sky. So we really want to get a handle on that noise and kind of how we're going to go about doing that. So what we might think to do on doing some sort of kind of big nebula type scene is to try and turn to the volumetric tools, which is really cool, but they do take a long time to render sometimes. Those times can be astronomical, but thank you. There might be several of those puns coming. Let's see. So basically what we want to do is take the noise texture, which is just on that color amp there. We're just using that to increase contrast a little bit, and then the power node is just to kind of change the fade of it a little bit. Some of these, but what we can do is really get noisy with the noise, is the point I'm trying to make here, which is just plug a noise texture into the noise vector. And then you can get, again, this is, you get like a much more sort of type of detail. There's far more contrast. I hope it kind of comes across in these images here. You get like a more definition. And then what you can do, instead of just going straight into it, to give yourself some more control, we want to be able to take the noise and kind of add it into the vector instead. The problem with that, though, and let's see if this slide even works, which it may not do. Which it's not going to do. But I'll just explain it. I'm going to somehow abstractly describe noise. All right, so basically the noise, when you add it like that, you're adding it only in positive values. So what happens is the noise has the appearance of basically sliding down into the bottom left. So just to kind of try and improve that a little bit, what we can do is we can instead subtract 0.5. Bartek Skorupa has actually covered this in pretty big detail, actually, a few years ago at the conference. And so we just set an RGB value of 0.5 and in the second socket there. And then when you end up basically getting to the next invisible slide, you would then see the fact that it kind of almost looks like a 3D. It sort of almost looks like it goes into a little bit more depth on that image, and it is actually looks far more convincing, which we'll hopefully see shortly. So at that point then, we have various different controls that we can just take out, which I've decided to put into that red frame on the side there. So various different values. What the key thing that I'm trying to point out on this one is that what really looks cool with that noise, to give it that extra bit of contrast, is to make sure the values for the scale, detail, and distortion are the same. So on the noise texture, that's informing the vectors, and the noise texture, that's informing the grayscale values that you end up seeing. So with that, we have, an image. So this is the kind of ideas that we did to try and sort of fade into the nebula, kind of just, or cloud, you can adjust this technique to sort of work with just as a clouds fly through kind of idea. It's quite low resolution on this screen though. I mean, you can go as high resolution as you want to. That's the whole point of it really. But on this little file, to try and make sure it works in the talk, it's just kind of scaled down a little bit. And so, yeah, rather than reaching for those volumetric shaders and so on, what we're doing instead is just tricking it. This is another kind of games technique you might do, and that's just a plane which is set into an array, and it's kind of got loads of those planes, and the camera just goes straight down. To be able to do that, to kind of explain kind of why that works, is because our noise, the amazing thing about the noise is that it is 3D noise. So you can see on this lower left, if you scale the noise and kind of create enough contrast, you can see the noise is all different, but it's obviously related. It's kind of packed together. And so that's the trick. When you kind of go through it and use your camera fade node that we talked about at the beginning, you don't get any of those hard transitions. You basically it just looks like you kind of taking volumetric slices, basically. So with that, you've got you can mix together various different sorts of noise. So on here, we've got the two sorts of noises. We have the just different scales, kind of combine them together. And the point I'm making here is just that it's really simple. That node at the end is just the distance fade, the group that you can see over here. That's just basically the same sort of setup that we talked about earlier on. And otherwise, you want to definitely, if you just leave it at that though, you might actually notice that what you're looking at is just pure white, which is probably would put off a lot of people, I think, at that point. Maybe just give up on the technique and kind of go, oh, whatever, I'll figure out a different way to do it. But if you kind of take the color values instead, all this stuff in this frame, again, pretty simple stuff. It's just a noise texture, and then we have the hue saturation value and a multiply. So if you take this multiply node, and then in this second socket, you just put a little color value and make it full white, you can basically just get something which sort of starts to tint the whole nebula, something of your choosing. And then you could just change the contrast. And then over here, you could also use the color management. So for example, like Filmic and this kind of thing. So with that, there's that noise as well, just to bring it back to what we talked about before, about making noisy noise. You can basically take these three nodes here have just been replaced with that whole node setup that you saw the insides of before. And you kind of get a lot more sort of definition. I mean, this is just noise, but it's starting to resemble a lot more of like a bit more authentic kind of large scale dust, I suppose. Okay, so what was here? Let's move on. Wormholes. So yes, this has been sort of looked at in lots of different ways. These various films, everybody always kind of has approached this subject in many different ways. The film Contact, 2001, and more recently Thor. And we can basically take a lot of that as inspiration. It's obviously like theoretical stuff. No one's been out there and taken any sort of reference images to create this sort of stuff. So we're kind of down to our own imagination on this one. The way we've tried to go about it is kind of this sort of idea. Again, it's very low resolution. you can kind of go as high detailed and as many frames as you want. So for this kind of thing, again, the idea is this could go on infinitely. You could just, as long as, however long the segment was, maybe it was supposed to feature for the entire length of a song or something, and you wanted to try and create like a massive loop or something along these sorts of lines. The way to get infinite detail on that is, again, to kind of take a look at procedural noise, but this time to just work it like this. So instead of actually the camera zooming down the geometry, we just take a bit of cylinder and then just add some extra bevels down the cylinder just to get that extra smooth geometry. And it's rigged using bending bones. And then at the very end, the very tip of the sort of wormhole there has a bone on there, and we're using this procedural noise this time. So we could just have this go and extend for as long as we wanted. Well, all we've done is place one keyframe, and then here in the noise is just our, again, just some procedural detail, and you just set that as to be as fast or as, you just change the scale and strength to kind of please whatever you want to do with it. So, with that, in general, we just learned a lot of interesting things about space. So, for example, this is to create a kind of a sun object. We learned that our sun is actually pretty surprising because, kind of important in a way, not just because it's given us all life, obviously. We obviously have a certain effect, we like it for a lot of reasons. But kind of an interesting from a scientific point of view is the fact that it's one of the most spherical objects in the visible universe that we can see. So it's a kind of an unusual thing. And I thought, that's quite cool. It's not most sort of celestial objects like this kind of are a little bit more wider around the waist, shall we say? We've kind of uncovered some interesting things that we enjoyed along the project. And asteroids, for example, this is not at all. Usually, well, as far as I'm aware anyway, you don't get this. Whenever you see kind of asteroid fields, and it's kind of, you can see from one asteroid to another asteroid, and it's like close, and something's flying through there, and it's dangerously, you're going to blow up or something. That just doesn't happen. It's much more likely that you would stand on one asteroid and then look out at all directions to try and look where the nearest other asteroid is and see nothing. So, is that good art? No, I don't think so. So you may have heard something like this. Before creativity is the art of concealing your sources. Which, or in other words, sometimes steal like an artist is another expression. So I think, I kind of see that as being a sort of, we're taking influence from something. We are doing that whether we like it or not. We are always influenced by our surroundings or our culture or whatever it may be. And so how I feel that's an important phrase is because if you are going to be influenced anyway, it's best to be deliberate about your influence. So kind of, take the ideas that you want deliberately and sort of, so you can be more direct and have more purpose with, hopefully be more effective with that idea. And in a similar way, kind of just to tie it together as a theme, we're sort of talking about just to cheat like an artist as well. So as we said at the start, it's like a whole suspension of disbelief. We want the audience to come along with us for the ride. And thank you for coming along on this ride as I've gone through all this sort of stuff. Thank you very much.